Thank you for joining today's STEAM lesson. Today's lesson is called Mars's First Network, and it will be given to 7th grade students in their computer science class. At this point in the year, students have been learning about what components of computer systems are and their relationships with one another. It's also important for students to know these components play a bigger role in shaping how we communicate in today's society. The goal of this project is to expose students to networking and how communication systems are built. They will also learn how to address wireless networking challenges and be able to troubleshoot and improve networks on a larger scale. Students will understand that when you plan a wireless network, you have to think about engineering specifics, like how to create lines of sight for radio waves to travel, and at the same time about social dynamics and how to get your neighbors to work together. Students will also understand that in building networks, it is also important to shape the technology to fit human relationships rather than to shape our relationships to fit the technology. This means making the wireless links between routers follow the social relationships that exist, or building new social relationships in the process of building the network. Ultimately, this project will help students to plan according to real world conditions and work around obstacles in our environments through problem solving and critical thinking. What's great about this project is that it connects students to all of the following STEAM disciplines. The science aspects, students will discover sources of interference such as vegetation, weather changes, microwaves, structures, and so on. For the technology portion, students will learn about different types of routers, switches, cables, wires, and transponders. When it comes to engineering, students will design a network that can be applied on a larger scale. And for the arts, students will create blueprints of what their networks will look like. And finally, for math, students will use geometry through exploring shape and space to find the shortest path around a map. They will also be responsible for planning, calculating, and following budgetary limitations. This project also addresses the following networking standards from the Massachusetts Digital Literacy and Computer Science Curriculum Framework. At the end of this project, students will be graded on the following rubric. They will be graded in the areas of design, hardware, budget, and reflection. As far as the hybrid and remote learning needs for this lesson goes, this lesson will be done synchronously. Both the students at home and in the classroom will be accessing the same materials at the same time with live instruction. All materials will be accessed through Google Classroom, and final artifacts will be turned into Classroom as well. The introduction and directions will be pre-recorded and posted to Google Classroom as a resource just in case students at home have technical difficulties and lose the live instruction feed. This way, students will be able to continue on with the project without the teacher in front of them having to tell them what to do. Here is an example of a challenge that students will work on leading up to this project. In the first slide up top here, you see that two neighbors want to connect their networks. They place routers in their windows, but they find that there's a weak link because of all the trees and vegetation that are in the way. So a solution for this would be moving the routers to a higher level, which will improve the link. So students will go through a series of these challenges before they make it to this project. Once they get to this project, the overview is as follows. The year is 2113. The Mars colony, Project LGM, has taken root. The colony has been thriving under Martian leadership for 10 years and is ready to establish some real infrastructure. You are a network engineer who has been tasked with designing your colony's first internet network. You've been given a budget by your green overlord, King Zamaj, and there's a list of other constraints. Design a network that is efficient, effective, and able to expand as your colony continues to grow and evolve. The constraints for the project is as follows. There are high priority areas that must have access to secure and fast connections. Residential areas must have close connections to entertainment areas. Each structure must be connected to every other structure in some capacity. You must remain under the $45,000 budget given by the king, and the network must be set up in a way that will allow it to be expanded in the future. When constructing the network, you're going to draw colored lines between each structure to create the network. Green lines are for the slowest and shortest range connections. Yellow lines are the middle tier of connections. Blue lines are the fastest and most secure connections. This symbol here represents the towers that act as signal boosters and relay points. Your budget to install your network is $45,000. Be sure to reference the constraints listed on the previous page to guide your thinking. Here is an example of what the map looks like. We have the map of Mars with all these different buildings and structures placed throughout the map. Below you will see a key to find which structure each icon represents. Here you will find the sample network that's been created. As you can see, there's been three access points or towers located throughout the planet, and each of the other structures are connected. Here is an example of what the budget table will look like. You're going to have the type of connection, you're going to have your low, mid, and high grade connections, how many towers you've used, the number of connections you have for each one, the cost per connection. Then students will have to do the math to calculate their total cost to make sure that they remain under budget. Finally, once this project is over, students will have to do a reflection. They will reflect on the strengths and weaknesses of their design and the challenges they faced during the project. They will also be asked to identify the STEAM components of the project and how it relates to their everyday lives outside of school. Students really will see how each of these STEAM disciplines are integrated with one another, and they'll be able to apply the skills that they learned here to future projects.